Muons can decay via the weak interaction into electrons and neutrinos. One such decay is, using a table provided, shows that in this decay lepton number, electron-lepton number and muon-lepton number are all conserved. Let's consider lepton number L. If a particle is a lepton and is particle, not antiparticle, its lepton number is +1. If a particle is a lepton but is antiparticle, its lepton number is -1. And if a particle is not a lepton at all, its lepton number is 0. So positively charged muon, it's lepton, but it's antiparticle, hence L is -1. Positron, it's also antiparticle, it's also lepton, so L is -1. Neutrino E, electron neutrino, it's particle, lepton, hence +1. Muon antineutrino, it's antiparticle, lepton, hence it's -1. So -1 is -1 plus 1 minus 1 is true, and it must be true because if some decay takes place, lepton number must be conserved. Let's consider lepton E number, electron-lepton number. And also, if a particle is lepton E, electron-lepton, and is a particle, not antiparticle, its lepton E number is +1. If it's electron-lepton but is antiparticle, its Le value is -1. And if it's not electron-lepton, its Le value is 0. So, muon, it's not an electron-lepton, so Le is 0. Positron, it's electron-lepton but antiparticle, so -1. Electron neutrino, it's particle and electron-lepton, +1. Muon neutrino, antineutrino, it's not electron-lepton at all, so it's 0. So 0 is -1 plus 1 plus 0, true, as required. Let's consider muon-lepton number. And also the same, if it's muon-lepton and this particle, not antiparticle, lepton mu value is +1. If it's muon-lepton but antiparticle, L mu value is -1. If it's not muon-lepton at all, this value is 0. So positively charged muon, it's antiparticle and muon-lepton, so -1. Positron, not muon-lepton, and 0. Electron neutrino, also not muon-lepton, 0. Muon antineutrino, it's muon-lepton, antiparticle, -1. -1 is 0 plus 0 minus 1, true, as required. Label the Feynman diagram below for the decay of a positive muon. So for a given decay, we need label the diagram. Notice that time is to the right, and notice that if an arrow is in direction of time, it's particle, and if it is in opposite direction to time, it's antiparticle. So initially there is muon, and after reaction we can see that there are positron and electron neutrino, and they always arise in pair, lepton E number to be conserved, and always positron is accompanied with electron neutrino, and electron is always accompanied with electron antineutrino. So here must be neutrino because it's particle, and here is positron because it's antiparticle, and here is antiparticle, which is muon antineutrino. And we also need find exchange particle since it's the weak interaction, possible exchange particles are W plus W minus Z0, and we should find the charge of the exchange particle. And if we consider any node, total charge in must be equal to total charge out. And if we consider, for example, this node, we can see that the total charge in is +1 and total charge after is 0, charge of antineutrino plus exchange particle charge of the exchange particle, so exchange particle hence positive charge, and since it's positively charged, it's W plus. And that's all for this question.